Hi micro folks, Professor Carberry here. We are now on day 3 of our grape and blueberry fermentation experiment. As you'll recall, we took some older grapes and blueberries and mashed them up, sampled them, made smears, took pH, and then we've been trying to hold them in under anaerobic conditions. So I tried to seal the plastic bags they're in and then put them in this mason jar. But you can see, you guys, that they've blown their seals, right? So probably from all the gas produced, and I see lots and lots of gas bubbles in here, you guys. They blew their seals, and now the juice is spilling out into the mason jar itself. But you'll recall what we were trying to do is see if we could select for the wild yeasts, the Saccharomyces, that carry out alcoholic fermentation, taking the plant sugars, converting them into ethanol and alcohol and carbon dioxide. And if we're getting alcoholic fermentation, some of those bubbles might be the carbon dioxide. That's what gives sparkling wine its sparkle, its carbonation. But folks, remember, we said when we started out, there's all kinds of microbes on our fruits, on our vegetables. And so we were trying to create conditions that would favor, right, give an advantage to the Saccharomyces. So that's why we tried to make it anaerobic. And what I just want to do, you guys, I haven't opened this today. I want to keep this up close to the microphone. So as I'm releasing the cap, maybe we can hear if any carbon dioxide, any gas is being released. This happened yesterday. I don't know about today. Nope. So maybe most of the CO2 was made maybe yesterday. It was so hot, right? The last 2 days over here, like around 100, 103. But just to review, you guys, we were sampling, transferring the microbes from the blueberries to the grapes each day. So I'll first do the TSA plates, and recall TSA is an all-purpose medium. It'll grow a wide range of both bacteria and fungi, including yeast. So here, folks, this was our blueberries, and you can see, you might recall that the blueberries were just so chock full of microbes. All the colonies grew together. We got confluent growth here. And then the grapes, this was the surface of the grapes. We can see the grapes didn't have as many microbes, but still quite a few, right? So based on the TSA plate, we know there's a wide variety of both bacteria and possibly fungi yeast growing on the grapes and the yeast. So then, folks, we processed the blueberries and the grapes. We squished them up right and tried to keep them under their anaerobic conditions for a day. And you'll recall, you guys, after 24 hours, even less than that, when I went out and checked the container, when I released the cap, there was gas escaping. So I was like, I think we had a pretty good fermentation going on. So then yesterday, then that would have been day 2, I took samples of the grape juice and the blueberry fermented juice, and I plated them onto TSA plates. And again, gosh, you guys, sorry, the contrast here isn't very good. So on this side, this is our grapes, and what I think I'm seeing in comparing the grapes from day 1, wow, I think we're getting selection for some kind of microbe here. Oops, sorry, that's the blueberry side. So on the grapes, you can see we're not getting the variety of colonies that we had before. I'll continue to let this plate incubate in our garage, and of course these colonies will get bigger, but it looks to me like we're seeing, like, maybe one or two of the microbes are winning out, right? We've got kind of a microbial competition going on in there, and maybe the conditions of it being anaerobic, maybe it's selecting, who knows, maybe for Saccharomyces, we're hoping. And we'll see, folks, boy, on the blueberry side, remember the blueberries on day 1, wow, what a mass of microbes. But then on day 2, and granted, you guys, this was a much smaller volume that I plated, but you can see we aren't seeing the variety of microbes that we saw on day 1. So again, I think there's some kind of selection going on. 1 or maybe 2 different types of microbes are kind of winning out. They're out competing the other microbes in our fermented grape and blueberries. And wouldn't it be wild, you guys, if there were wild yeast carrying out alcoholic fermentation, they're making ethanol. Maybe the ethanol is inhibiting some of the other microbes, right, that these little guys are competing with. So what we'll do, folks, is I'll take samples So this would be our day 3 after 48 hours of incubation, and I'll take samples and I'll streak to a new TSA plate. And then again, folks, you'll recall that we also plated our samples to Sabrode's dextrose media, SAB media, and this is selective for fungi, meaning it should inhibit most of the environmental bacteria and permit the growth of fungi, and yeasts are unicellular fungi. And again, we saw in the blueberries just such thick growth here. And again, on the grape side, we didn't have as much growth. But gosh, you guys, we sure have a lot of growth on the SAB plates, which suggests to me that we have at least one kind of fungus here. And what I'm hoping is some of these colonies, perhaps both on the grapes and the blueberries, are our wild yeast, our Saccharomyces. And then as a follow-up, folks, after 24 hours of incubation, we took some of the fermented samples and we plated again to Sabrode's dextrose media. And it's a little bit harder to interpret, but it just as we saw with the TSA, you guys, it looks like some of our microbes are outcompeting the others, right? Especially on the blueberries. And gosh, you guys, I forgot my dark paper. Maybe I can use this so we can see better. Okay, I'm not sure of that. No, that really doesn't help. But on the blueberry side, I don't see as many different types of colonies suggesting that maybe 1 or 2 of the fungi are outcompeting the others. Okay, obviously I have a lot to learn about making videotapes here, you guys. And also on the grape side, it looks like we're getting selection for maybe one single type of fungus. And again, we're hoping it's the Saccharomyces. Yesterday, when I opened up the blueberries and grapes, I got this whiff of alcohol. So I thought, I think somebody's in there doing an alcoholic fermentation. And again, folks, what we've been doing each day is we're taking some of the juice from the grapes and the blueberries, and we're making a smear on a microscope slide and then heat fixing it. And then next week, I'll take those slides into the microlab at Sac City and I'll gram stain them. And it will be really easy for us to tell if we have yeasts, because they're relatively large oval cells that have a cool way of reproducing called budding. And then our bacteria, most of them will be much smaller and they won't be budding. And we'll be able to identify the shapes of the bacteria. Are they little balls like cocci or little sausages called bacilli, right? And then the final thing that I'll do today, you guys, is take the pH. And I'm using our really cool pH strips. And we started out around pH 3 to 4. And after 24 hours of fermentation, the pH hadn't changed very much. You know, pH 3 to 4, it's already pretty acidic. And do remember, you guys, in alcoholic fermentation, we aren't making any acid, so I'm not surprised that the pH hasn't dropped. Now, in the other fermentation experiment we're doing, lactic acid fermentation, I'm hoping we'll see a pretty dramatic drop. Well, we're fermenting cabbage, so the cabbage pH started out at about pH 7, and I bet it's going to drop to about pH 3 or 4. And after this video, we're going to do a milk lactic acid fermentation. And again, I think we should start out, the fresh milk should be around pH 7, and after lactic acid fermentation, it should drop it to about pH 3 or 4. So with lactic acid fermentation, it's the lactic acid the bacteria are making that are inhibiting the spoilage microbes, okay? So I think that's it, folks. So we'll just keep that short, and we'll do one more video on lactic acid fermentation of milk. Okay.